When we start building microservices or a distributed system for the first time, we usually believe everything will just work fine. The network will always be up, the services will always respond instantly, and nothing will ever break. But the reality is completely different. Those assumptions always come back to bite you. There is a famous list called 8 fallacies of distributed computing. Now let us understand what are those. The first false assumption we make is believing that the network will always be reliable. When building a distributed system, it is very dangerous to assume that the network that connects your components will always work fine. Networks are naturally unreliable. I mean, packets can be dropped, connections can be interrupted, and data can become corrupted during the transmission itself. Now imagine you are ordering a pizza online, and after selecting your favorite pizza, you clicked on place order. But unfortunately, your internet lags for a moment. Now you are not sure if the order request went through or not, so you click again. And after few minutes, two delivery guys shows up at your door with similar orders. That is what happens in distributed systems too. Sometimes your request never reaches the server, or sometimes the server processes it, but the confirmation message gets lost. So in those scenarios, you try again and the system may end up doing the same thing twice. That's why developers add retries, timeouts, and idempotency. Because in the real world, you just can't trust the network to be reliable. If you assume the network will never fail and skip handling these retries, timeouts, and idempotency, it will come back to haunt you in production. And trust me, it won't be pretty. To build a robust system, you need to accept and plan these potential failures. So always remember, the network will fail because it is not in your control. So always design your system like it will always fail. We often assume that everything happens instantly. We click something on the user interface, and at the backend, one service calls another, and data just flies across the network. But reality is little different. In distributed systems, when you click on a button, it calls one service, which calls another, and so on. It makes a chain of hopping service calls. Now, each hop adds a latency. So don't assume the latency will be zero. Instead, design with caching and asynchronous calls in mind so that you can minimize the overall response time. Another common assumption we make is there is always enough bandwidth. Bandwidth is the amount of data that can be transmitted in a given time. For a moment, think about your home Wi Fi. You are watching your favorite show and suddenly it starts buffering. Why? Because everyone else in the house just started streaming their own videos. So your connection didn't disappear, it just got crowded. The same thing happens in distributed systems too. So when multiple services send large amount of data at once, the network will slow down, packets will queue up, and the response will start taking longer. Now, sending more amount of data in a single request doesn't always means better performance. That is why smart systems use response compression, pagination, and streaming to move data efficiently. There is a balance that we need to establish between minimizing the latency and saving the bandwidth. We should transfer more data in fewer trips to reduce latency, but we need to send less data overall to save the bandwidth as well. Another assumption we make is that network is secure by default. Now, assuming the network that we use is secure is a big mistake. Security should be our top priority. Malicious users like hackers constantly try to intercept and decode the network communications. This makes data encryption and security more important and critical. In the world of microservices, where all the services communicate over a network, sometimes across regions, clouds, or even in the public internet. So, if you are not careful, sensitive data can be leaked and requests can be intercepted. That is why, as a developer, we should secure our communication using HTTPS, TLS, authentication tokens, and API gateways. We need to make sure that each request is verified, encrypted, and monitored. So when we design our system, we should not assume the network will protect us. We need to plan with zero trust in mind. So assume nothing and secure everything because network is never as safe as you think. Another assumption we often make is that network layout of our system, that is which service talks to which service, is fixed and predictable. The network structure isn't static. It changes frequently, sometimes due to some components crashed or we add or remove components on purpose for scaling up and down. If your system assume a fixed structure, then the calls will either fail or end up in a wrong place. That is why we should use service discovery, dynamic routing, and load balancing. In this, instead of hard coding where to send the requests, services ask the systems where is the right instance at that moment. So when designing, never assume the topology is static. The network changes all the time. So design your system to find the best path dynamically. Another assumption we make is that a single person controls everything in the system. But think of it like running a huge office building. We imagine that one manager handle all the floors, departments and facilities. But in reality, there will be different teams for, let's say, security, IT, maintenance, and other services. If one person tried to do it all, then things will break very easily. In large microservices systems, different teams own different services. There is no single person who is having full control and knowledge of everything. Assuming otherwise would lead to the confusion and miscommunication. That is why we should design the system with clear ownership, team boundaries, and well defined interfaces. Now, another assumption that we make is that sending data across network is free. But think of it like sending a parcel. Every time you ship something, it takes time, it will cost money, and it will require handling. In microservices, every network call has a cost which can be in the form of time, resources, and money. That is why we should avoid unnecessary calls. We should cache the results for better performance and batch multiple requests whenever possible. So when designing our system, we should always remember network calls are not free. Every request comes with a cost. Now moving to the last assumption. We often think that all the parts of network are same. That is same speed, same reliability and same topology, which is not the case in real world. Suppose you are on a road trip. Some roads are smooth highways, some are bumpy and some have traffic jams. No matter how fast your car is, you cannot drive at the same speed everywhere. In distributed services, not all networks and components are equal. Some services may run in the same data center, or some across regions, or some in a completely different cloud. Latency, bandwidth, and reliability will vary for all those components. That is why we should design with the network variability in mind. So always remember, networks are heterogeneous. We need to plan for differences, not for uniformity. I think we have seen enough assumptions for today. So when designing any distributed service, don't assume the world is perfect. Assume everything will fail at some point and make sure your system is strong enough to survive it. That is how great architectures are built, not on assumptions but on reality. So that is it for today. If you think this video was helpful, don't forget to like, share and subscribe. Also press the bell icon so that you won't miss any new update. I'll see you in the next video. Till then, let's keep learning.